A hollow hoop rolls along a surface. The hoop has a mass of 4 kilograms and a radius of 3 meters. It has a translational velocity of 8 meters per second. What is its total kinetic energy? For any problem like this, you need to begin by recalling the equation for total kinetic energy. And the equation for that is, well, total kinetic energy, U sub k means kinetic energy, equal to translational kinetic energy added with the rotational kinetic energy. Because there's two types of kinetic energy. There's translational and there's rotational. And basically to find the total of it, you just add the translational and the rotational together. All right, then you can derive the translational kinetic energy into the equation we learned, which was 1/2 mass times velocity squared. And now you need to understand that the rotational kinetic energy is going to be the same, but instead of these two variables, it's going to be in terms of rotational kinetic energy. So it's going to be 1/2. Instead of mass, we're using inertia, times instead of velocity, we're using angular velocity, which is omega squared. Okay, so UK total. These two are the same thing. Now moving on, we are going to realize that we're working with a hollow hoop, which means that for the moment of inertia, we're going to base it on the equation for the hollow hoop, and the equation for a hollow hoop is 1 mass times radius squared. So it's that. But side note, on questions like these, there are three shapes you'll be working with. You'll be working with a hollow hoop. You'll be working with a solid cylinder. And you'll be working with a sphere. And for hollow hoop, it's I equaling to mr squared. For solid cylinders, it's going to be I equaling to 1/2 mr squared. And for spheres, it's going to be I equaling to 2/5 mr squared. All right, but that's that. You don't need to remember all these right now, but just know that if you remember just 3 of these equations of moment of inertia equations, you can solve any type of problem similar to this one. And I'll make videos for the other 2 shapes just for you to see. Okay, let's take this out to create more space. Now, the second thing you need to know is this problem doesn't state omega. So we need to understand that omega is the same thing as velocity, but what makes it different is that it's in an angle, so it's rotational. So you can rewrite omega as velocity over the radius, because this is what is going to make it rotational velocity. Okay, so rewrite this. You have U sub k total, the total kinetic energy, equaling to 1/2 mass times velocity squared plus 1/2 mass times radius squared multiplied by omega, which is v over r squared. But see, now you can distribute the squared to both v and r because you know omega is squared here. So rewrite this again. You get UK total equaling to 1/2 mass times velocity squared plus 1/2 mass times radius squared times velocity squared over radius squared. All right, same thing. Now you can use canceling to cancel r squared and r squared right here, which will leave you with UK total equaling to 1/2 mass times velocity squared plus 1/2 mass times velocity squared. Okay, now is where it gets exciting. So I'm just gonna remove this to create more space. Now we write in what we know. We know that mass is equaling to 4 kilograms. Okay, so I'm just gonna write 4. We know that kilograms. The radius, r, big R, little r, stands for radius, is equal to 3 meters. And we know that the velocity is 8 meters per second. Oops, velocity equals 8 meters per second. Okay, once you get that out of the way, you plug and chug. So you now have UK total equaling to 1/2 mass, which is 4, times velocity, which is 8 squared, plus 1/2 mass, which is 4, times velocity, which is 8 squared. Whip out a calculator, plug in those numbers. 1/2 times 4 times 8 squared plus 1/2 times 4 times 8 squared, you get 256. So this is going to be 256 joules. There you go.